Hey guys, this is going to be a video of me going over the Chapter 4 practice test. I figured that this might be useful just in case that you miss the review day or there are some questions that we weren't able to get to. Hopefully this helps you see how I approach the questions. So let's just start here with 1 through 6 right here. In 1 through 6 you'll see it gives you a function f of x and a function g of x right here, and it says to perform the indicated operation. So for number 1, f plus g of x. So for f plus g of x, I'm going to take f of x, which is x squared plus 4, and I'm going to add to it 2x minus 1. Now, because I'm adding, the parentheses don't really do anything, not necessarily needed. So what I'm looking to do is just combine any like terms. So there's no x squared term in the other one, just the one x squared term. So x squared, no other x term other than the 2x, so plus 2x. And then I have the 4 and the minus 1, so that's going to be plus 3. So this right here is my f plus g of x. For number 2, it's f minus g of x. So again, I'm going to take my f of x, which was x squared plus 4, and I'm going to subtract 2x minus 1. And here, the parentheses will make a difference because that negative has to be distributed to both the 2x and the negative 1. So that's going to make it x squared plus 4 minus 2x, and then it's going to be plus 1. Okay, and so my f minus g of x, looking for terms I can combine, that's going to be negative 2x after that, and then the 4 and the 1 is going to be plus 5. And there's my f minus g. Okay, let's try here. This is f times by g, so I'm going to take my f of x, which was x squared plus 4, I'm going to write that in parentheses, and I'm going to multiply it by 2x minus 1. Okay, and since it's a binomial multiplied by a binomial, I'm going to FOIL this, so multiply the first terms and then the first outer term, so that's x squared times 2x, that's going to be equal to 2x cubed. X squared times by negative 1 is minus x squared. Now I'm going to multiply the inner terms and then the last terms. So that's going to be, let's see, positive 8x and then minus 4. That's going to be equal to, well, actually that's going to be it right there, since there are no like terms there. So here's my f times g of x right there. F divided by g, so f divided by g of x is going to be equal to x squared plus 4, which is my f of x, divided by 2x minus 1. And there's really nothing you can do here. That's pretty set right there. So you might just need to mention that for the domain, 2x minus 1 cannot equal 0. And I'm just going to solve this. So 2x cannot equal, I'm going to add the 1 to the other side, then I'm going to divide both sides by 2, so I get x cannot equal 1/2. So just that's going to be a domain restriction there. And for 5 and 6, looks like these are going to be the composition of functions. So as you can see here, we have f of g of x, meaning that g of x is going to be plugged into f of x. So f of x, let me go up here, remind myself, is x squared plus 4. So I'm just going to write this above. F of x is equal to x squared plus 4. G of x is equal to 2x minus 1. I'll just write it here so I don't have to keep scrolling up. But essentially, g of x is the inside function. So I'm going to take this and I'm going to input it into the x location into f of x. So f of g of x is going to be equal to 2x minus 1 squared. So again, this was where the x was right there. So I'm just going to replace x with the 2x minus 1, and then plus 4, just like that. And that should generally be pretty good right there. But I can expand this right here. So I'm going to do that. So it's going to be equal to 2x minus 1 times by 2x minus 1 plus 4, because being squared is to multiply it by itself 2 times over, and I'm going to FOIL this out. So the first term's 2x times 2x is 4x squared. 2x times by negative 1 is minus 2x. Negative 1 times by 2x is minus 2x. Negative 1 times negative 1 is positive 1, and then plus 4. And then let's go ahead and clean up a little bit. So the 4x squared, this is going to be negative 4x when I subtract those together, and that's going to become positive 5. And so that should be that right there. Okay, for 6, looks like we're going to do a very similar process, except this time we're going to do the other way. So instead of putting g of x into f of x is going to be placed into g of x right there. So my g of f of x going to be equal to 2, and then I'll have x squared plus 4, and then minus 1. So you can see that I have this same thing, it's just that instead of x, I'm inputting f of x into that x location. And then I just have to distribute that 2 inside. So that's 2x squared plus 8 minus 1. That's equal to 2x squared plus 7 right there. And that's my g of f of x right there. Okay, so that should be the first page right there. Alright, so for 9, looks like we're trying to simplify 9 through 17. Looks like for this page it's just to simplify. Okay, so I see I have a third root right here with some numbers and some variables. So what I'm first going to do is to figure out the third root of 192. Now, because this is being multiplied and being multiplied like that, I can evaluate each of these separately, find the third root of them separately first. So, okay, so let's think about this right here. I have the third root of 192. Now, the 192, you can go ahead and check right away if it's possible to do that, but if I get a decimal number, then I'm going to have to try something else. So we got third root of 192, that's a decimal number, okay? So I'm going to have to find something else. So what I want to do is I want to see if there are any factors of 192 that you can take the third root of. Okay, so let me generate a list of cube roots, perfect cube roots. So that's going to be 1 to the third, which is going to be 1. 2 to the third, which is going to be 8. 3 to the third, which is going to be 27. 4 to the third, which is going to be 64. 5 to the third, which is going to be 125. And I think that's a pretty good list right there. So 8, 27, 64, 125. So 8, 64, right? That's what we said. 8, 27, 64. And then 125. And then what I want to do, if I want to see if any of these numbers are factors of 192, but I also want to see which of the largest one. I don't think 125 is going to go into 192, so let me start with 64. So 192 divided by 64 is 3. So there we go, we already found it. So 192 divided by 64 is 3. times by 3 is going to give you 192. So I have the third root of 192, which is equal to the third root of 64 times by 3. Okay, and then, well, let me go ahead and just add this. So we got 8 by cubing that right there. Then we had 3 cubed, then we had 4 cubed, and then we had 5 cubed. So that means the third root of 64 is going to be 4. So I can go ahead and evaluate this. Since I know that 4 times by itself 3 times is 64, this is going to be equal to 4 cube root of 3 right there. Okay, now you can already kind of tell that the only option available there is C, because we figured that out right there. So that's pretty good, but let's just go ahead and solve the rest of it. So I have u to the 7th and third root. So third root of u to the 7th. Now I know that 3 goes into 7 twice with 1 left over. So that's going to be u squared because it goes in twice. And then I'll have the third root of u, and that's the 1 left over. So that means on the outside I should have a u squared. So it can't be this one right here. That's not a u squared. That's not a u squared. So it could have been that one or that one right there. And you can kind of see that, again, C is our only option because there's a u left over on the inside. This one does not have that. Okay, and then for the last part, that'd be the third root of v. And since we can't group v into any groups of 3, then that would mean the v would have to remain. And so that would again leave us with option C and not this one right here. Alright, so for 10, it's a very similar process except we're using fourth roots. So let me go ahead and generate a list. So 1 to the 4th is, of course, 1. 2 to the 4th is 16. 3 to the 4th, I believe, is 81. Let me just double check that. Yep, it's 81. And this has already gone way too far. That's way too far to go into 48 because that's what I'm looking for. Since I can't take the 4th root of 48. Let me just double check that though. So we want the 4th root of 48, which I get a decimal number. Okay, so then I'm going to look for factors of 48 that work. Now that's way too large. That's not going to be helpful. So I'm really only left with the one option. So it has to be 16. And is 16 a factor of 48? And yes, it is. It goes into it 3 times. So that's going to be 3. So when I take the 4th root of 48, okay, so this is going to be equal to the 4th root of 16 times by 3, and the 4th root of 16 is 2, so I get 2 4th root of 3. Okay, so that's going to leave me with options A and B. It can't be C or D. Okay, now let's go ahead and go to the 4th root of x to the 8th power, and that's going to be equal to 4 goes into 8 2 times, so it's going to be x squared. So this has to be on the outside, and none is going to be left over on the inside. And then I have the 4th root of y squared, which is just, I can't take anything out, so that's just going to be the 4th root of y squared. So anything left inside is going to be 3y squared, and on the outside, so I have to have a 2, I have to have an x squared. So that's a 2x squared, so it looks like A is going to be my answer. 2x squared on the outside. On the inside, I should have 3 and a y squared. Alright, for option number 11, to simplify this, so looks like I'm adding and subtracting radicals. So first thing I'm going to look and see is if I can combine any like radicals. So this is a square root of 3, that's a square root of 3. So because these are the same, I can add these coefficients together. So the negative 3 and the 6, that's going to be, so I have 2 square root of 18, and then 6 minus 3 is going to be positive 3 cube root of 3. remember that the radical inside stays the same. And that's none of our options here. That just means right here I have to simplify this expression most likely. So kind of like the same thing that we did up here, we're looking for a square root. So right away I already know that 18 is divisible by 9, and 9 is a perfect square, so 9 times by 2 plus 3 square root of 3, and I know the square root of 9 is going to be 3, so it's 2 times 3 square root of 2 plus 3 square root of 3, and then that's going to multiply into be 6 square root of 2 plus 3 square root of 3, and looks like that's going to be option number D. Alright, let's go to 12. I have I have binomials, it looks like, so I'm probably going to want to simplify this by multiplying, and that I'm going to need to FOIL. So 4 times by 2 is going to give me 8. 4 times by square root of 5 is going to be plus 4 square root of 5. Then 3 square root of 5 times by 2. 3 times 2 is going to be 6, and then square root of 5. And then let me clear this up a little bit so I know what I'm doing. So 3 square root of 5 times square root of 5. Well, square root of 5 times square root of 25. Square root of 5 times square root of 5 is equal to the square root of 25, which is equal to 5. And then I have that 3 right there. So that's going to turn into plus 3 times by 5. Okay, so I have 8. And because these are like radicals, because they're both square roots of 5, I'm just going to add the coefficients. So plus 10 square root of 5. And then plus 3 square root of 5. Again, I have, oh wait, that's not going to be a square root of 5, just kidding, that's going to be 15 right there. So plus 15, but then I could add those together, and then that's going to be 23 plus 10 square root of 5. Looks like that's my option D. Alright, moving along to number 13. Some multiplication. So what I'm going to do here, since I can already see that obviously the square root of 16 is 4, square root of 25 is 5, so that's going to be 2 times 4 square root of x cubed times by 5 square root of x. Now anything that is outside of those radicals I'm just going to multiply together, so 5 times 4, that's going to be, excuse me, that's going to be 20. 20 times 2 is going to be 40, so I have 40. Now, because these are both square roots, I can multiply them together. So it's going to be square root of x to the 4th, since x cubed times by x is x to the 4th. And then x to the 4th, since this is a square root, 2 goes into 4 twice, so I'll have 40x squared. So that's how that one can simplify right there. Excuse me. For number 14, it's division, and it's both underneath a radical. So I can evaluate them separately. So let's say square root of 32x divided by square root of 9x to the 4th. I'm going to start with the denominator, since that one looks quite easy to solve. So I'll evaluate the numerator in just a bit. But I know square root of 9 is 3. And the square root of x to the 4th, since it's a square root x to the 4th, that's just going to be x squared. Okay, now the 32 needs to be simplified if it can. So let's see, 16 goes into 32, and 16 is a square root. So that's going to be square root of 16 times by 2 times by x over 3x squared. That's going to be equal to 4 square root of 2x divided by 3x squared. And I think that's all you can do right there. So can't really do anything else with on the numerator, since you can't take the square root of 2. And you can't take the square root of x. You can't factor it. You can't take anything out. So I think that's good right there. For 15, so we don't want any radicals in the denominator. In order to get this out, since it's a binomial, I'm going to want to multiply by its conjugate, which is the same thing, just different sign in between them. So 3 square root of 2. But that means I have to multiply the top by the same thing. Okay, now we're going to have to use some distribution here. So on the top, I have to distribute the 5 to both terms. So it's going to be equal to 15 plus 5 square root of 2. Okay, now on the bottom, 3 times by 3 is going to be equal to 9. Now, the good thing about multiplying by a conjugate is that the outer and inner terms are going to cancel. So you can see that's 3 square root of 2 positive. But then this is 3 square root of 2 negative. So they're going to cancel anyways. So I'm just going to skip that part right there and just multiply negative square root of 2 times by 2, which is going to be equal to negative 2. So I have 15 plus 5 square root of 2 divided by 7. And that's it right there. No radical on the denominator. And we're good. For 16, so I'm going to use my exponent, properties of exponents. Because my powers, these powers both have a base of x, I can add the exponents. So x, which is my power, that's going to be 2/3 plus 5. I'm going to make this a fraction right there, 5 over 1. In order to add them, I need a common denominator, so multiply by 3 on both those. So I get x to the 2/3 plus 15 divided by 3, and it's going to be equal to x to the 17/3. For 17, very similar. I have two powers on numerator denominator, but because they're the same base, I can subtract their exponents. So a to the 6/5 minus 1/2. To get a common denominator, it would have to be 10. So multiply by 5 and 5. Multiply by 2 and 2. So I get a to the 12 over 10 minus 5 over 10. That's equal to a to the 7 divided by 10. Okay. Alright, 18, it says write the radical, so this is a radical, using rational exponents and simplify as needed. So there might be two parts right there, so watch out for that. So rational exponents, so what I do know is that a to the nth root of a to the m is equal to a to the m divided by n, so where the index number becomes the denominator in a fraction. So this is equal to x to the 6/4. Now, because that is a reducible fraction, I'm going to call that x to the 3/2. So that would be the second part, simplify as needed. So there you go. Just remember that I could, if it's an index number, the index number I could write as the denominator in the exponent. And I can do the same thing here. So it's going to be the denominator of both of those right there. So this is going to be equal to a to the 2/3 and then b to the 6/3. And this is equal to 2. So that's a to the 2/3 and then b squared. Okay, so that's the two parts. So write the radical using rational exponents, which we did. Simplify as needed. That's going to be the simplifying part right there. Okay, write each expression in radical form. So this is the opposite. So we're using the same thing, but we're going in reverse. So if it's in a radical, or in if it's in an exponent form, we're going to write it as a radical. Just remember the denominator is going to be your index number. So this will be equal to the third root of 7r, and that's it right there. No simplifying needed. Can't do anything else. And then here, notice that this is in parentheses right here. So the whole thing, and that's the same thing over here. This is in parentheses, so that means the whole thing has to go underneath the radical. So this is going to be equal to the fourth root, because that's my denominator, of 2x, and then raised to the 7th. Now you could have also written this as equal to the fourth root of 2x to the 7th. Just note that it can't be x to the 7th, only x to the 7th, so that's why I have these parentheses right here to indicate that the 7 applies to both the 2 and the x, because that's how it was given to me. It was in parentheses like that. So the power of 7 and 4, that whole thing applies to both the 2 and the x. So that's why the parentheses are necessary. Okay. Let's see. Let's go here. Solve each equation or inequalities, and remember to check for extraneous solutions. So that's going to be an important part right there. Okay, so the rule, or what you should be doing, is you should be getting the radical isolated. So I'm going to divide both sides by -4. First of all, get the square root of n minus 6 is equal to 10. And then I'm going to want to square both sides. Okay, so then I get n minus 6 is equal to 100. And then I'm going to want to add 6 and add 6. So then I get n is equal to 106. And if you guys needed to, you can do a check, which I do recommend doing. You can always plug it into your calculator, but that's going to be -4 square root of 106 minus 6. Is that going to be equal to 40? So this is going to be -4. Well, 106 minus 6 is 100. And then I get -4 times by 10. That should be equals -40, and that's equal to -40. So looks like it does check out. Now, it's not required that you show how you check your answer, but if the solution is not a solution and you leave it as a solution, you will be marked for it. So just so you know. Try 23. So for this one right here, the radical is already isolated. So I'm just going to go ahead and get rid of the radical and cube both sides. So then I get 5x plus 1 is equal to -4 cubed is -64. And then from here, I can subtract 1. So subtract 1, subtract 1. So I get 5x is equal to -65. And then divide by 5. I get x is equal to 65 divided by 5 is 13, so x is equal to -13, and we can do a quick check. So I got the cube root of 5 times by -13 plus 1 equal to -4. So that's going to be the cube root. Well, we know 5 times by -13 is going to be we did that. That's -65. So -65 plus 1. That's the cube root of -64. And the cube root of -64 is -4. So it does check out. Alright, for 24, for this one right here, it's already isolated. So let's go ahead and get rid of the radical by squaring both sides. Now just remember here that this is equivalent to x minus 7 times by x minus 7. So that's going to have to be distributed. It's equal to x minus 5. So this is going to turn into x squared minus 14x, because that's minus 7, that's minus 7x. And then -7 times -7 is positive 49. It's equal to x minus 5. Now it is a quadratic, so I'm going to move these terms over here and see if it's factorable, and it might just need to be, you might have to use the quadratic formula, but let's see what we get. So let's subtract an x, and add a 5, add a 5. Okay, so then I get x squared minus 15x, and that's going to be plus 54 equal to 0. Sorry, let me rewrite this in blue. X squared minus 15x plus 54 equal to 0. Okay, so now what I want to do is check and see, since this is a quadratic, and I want to see if it's factorable, so what numbers multiply to be 54, but will add to be negative 15. So 54, that's 1 in 54. 2, see, 54 divided by 2 is going to be 27, so neither of those work. 54 divided by 3 is 18. So 3 and 18 might work, except this is positive and this is negative. So I don't think there's any way that would work. So I don't think those work, because this would have to be negative 18, positive 3, but this is positive 54. So so both have to be negative or both have to be positive, which would not add up to be negative 15. So 54 is not divisible by 4, 54 is not divisible by 5, 54 is divisible by 6, so it's going to be 6 times by 9. Okay, so negative 9 and negative 6. That still is going to multiply to be positive 54, but it's also going to add to be negative 15, so x minus 6 and x minus 9. And then, so I know x is equal to 6 and x is equal to 9. And I'm going to check both of those to make sure that they work. So let's see. Let's go ahead and try 6. So if I plug in 6 into the top, I get 6 minus 7 squared equal to the square root of 6. Sorry. Minus 5, square root of that. Okay, so then this is going to be equal to negative 1 squared equal to the square root of 1. And then that's going to be equal to 1 is equal to 1. So I do believe that 6 does work. Okay, let's go ahead and do another check, but for 9. So I'm going to have 9 minus 7 squared equal to the square root of 9 minus 5. Okay, so then this is going to be equal to 2 squared equal to the square root of 4. So then this is going to be equal to 4. That's going to be equal to 2. Since those don't work, so it looks like x does not equal 9. So you just have to make sure that if you wrote this as a solution, maybe you cross it out. Okay, so make sure you double check that. And then again, you could always use your calculator as needed. So if you want to see, I can show you an example of how you can do that. Let me just pull up my calculator. So let's say, let's try 9. So you should have an option in your calculator to store that. Okay, so I got 9. And then we have x, I can type in x minus 7. That's equal to 2. And then I can do the square root of x minus 5. So, oh wait, did I do that wrong? Oh wait, I forgot to, oh wait, that's what I did wrong, sorry. That's not being squared right there. Oh, so I messed that up. I was looking at that right there. So in that case right here, that's not being squared, that's not being squared. So I think I got these backwards right here. So that's 9 minus 7, which is equal to 2, which is equal to 2. So it looks like x is equal to 9, but that would mean up here, in this check right here, that's not the case right there. That's negative 1. And then we're only using positives, so this is negative 1 is equal to 1, so this does not work. So right there, that's not going to be the solution right there. Okay, so good thing I checked. Alright, so that should work. Okay, let's try 25. So 25 is an inequality, so we've got the square root of 3x plus 10 is less than or equal to 8. So let's go ahead and square. Oh, first thing what I'm going to do is check my domain. My domain, remember that the radicand has to be greater than or equal to 0. So I'm going to solve this first. So minus 10, minus 10. So I get 3x is greater than or equal to negative 10. Divide by 3, divide by 3. Get x is greater than or equal to negative 10 over 3. So that's the first part, and let's see if it actually means anything with our equation. So let's take this right here, 3x plus 10 is less than or equal to 8, and let's go ahead and square that side, and square that side right there. So 3x plus 10 is less than or equal to 64, and then we'll subtract 10, subtract 10, and then I get 3x is less than or equal to 54, and then I'll divide by 3, divide by 3, and that's going to be equal to 18. So I get that x is less than or equal to 18. So that does check out with that. So we're going to have x is less than or equal to 18. And then less than or equal to negative 10 thirds. So this does make a difference. So x has to be greater than that number, but also has to be less than that number. Okay, so that would be the final answer that you need. All right, let's do some graphing for 26. So graph the function, state the domain and range. So we have 2 square root of x plus 5. So there are two transformations here. That's plus 5 and 2. Now, just as a reminder, the parent function of the radical function of or square root function starts here, 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 and then here. So one thing that we're doing here is that we're shifting it up 5, but then we're also stretching it by 2. So let's see, that would put it 1, 2, 3, 4, 5. That would put it right there. Okay, and then to kind of just see where the rest of them are, I'm going to plug in 1 into the function. So I have 2 times by the square root of 1 plus 5. So that's going to be equal to 7. So that's going to be right there. And then I'm going to plug in 4. So 2 square root of 4 plus 5. That's going to be equal to, well, that's going to be 2. So that's going to be 4 plus 5. That's going to be equal to 9. So then when x is equal to 4, y is going to be equal to 9. And I think that should be pretty good right there. Got a good idea of what's happening there. The domain, the radicand has to be greater than or equal to 0. So x has to be greater than or equal to 0. You can kind of see that happening here. Our function is greater than or equal to 0 on the x. And then for the y, you can see that it's greater than 5. So y is greater than or equal to 5. All right, let's try this one right here. So a negative, that's going to mean it's going to be reflected over the x-axis. And then right here, that's going to be to the right 2 units. So that's where it's going to start. So it's like you're taking this here. If this was the parent function, it's got to go over to the right and also has to be reflected. So those are the two things that's happening there. So then you can plug in some points. So you can plug in 3 if you need to. So it's going to be negative square root of 3 minus 2. That's going to be negative square root of 1, which is equal to negative 1. And then let's see, we could plug in 1, 2, 3, 4, 6. 6 would be a good number because then I get this negative square root of 6 minus 2. And 6 minus 2 is 4, so I get negative square root of 4. So this is going to be equal to negative 2. So right there, and that should probably be good enough right there. So there's your graph. Domain, you can take the radicand, so x minus 2 is greater than or equal to 0, and x has to be greater than or equal to 2. The range looks like y is less than or equal to 0. You can kind of see that here, it's just less than that. Okay. For 28, 29, identify all the transformations. Okay, so here we got square root of x. I think there's 3. 1, 2, and 3. So I'm going to say reflection in the x, and it doesn't have to be in any particular order. Reflection in the x-axis looks like that's a vertical shrink. By a fourth, and then up 1 unit. Okay, so I think that's all of them there. For 29, I see 5. I see 3. So multiply by 5, minus 6 underneath the radical, minus 2 on the outside. So vertical. Stretch by 5. That's going to be to the right 6 units, and then down 2 units. Okay. For 30, find the inverse of each function. Now, the steps for finding the inverse is make it y is equal to the square root of x minus 1, and then to swap the locations of x and y. So x is equal to the square root of y minus 1. So we're going to add 1. We're going to solve for y, so solve y by adding 1, so plus 1 plus 1. So I get x plus 1 is equal to the square root of y. And then I'm going to square both sides, square and square. So I get y is equal to x plus 1 squared. And as we all know, that's x plus 1 times by x plus 1. So y is going to be equal to x squared plus 2x plus 1 whenever you FOIL that all out right there. Okay, so there is your inverse function right there. Alright, so then for 31, we have negative 2x plus 5, so let's make this y is equal to negative 2x plus 5, and then we'll swap x and y, so x is equal to negative 2y plus 5, and let's solve for y. So I'm going to subtract 5, so x minus 5 is equal to negative 2y, divide by negative 2, divide by negative 2, and get y is equal to x minus 5 divided by negative 2. And there's your inverse function. Alright, I think these are the last two, so determine whether the functions are inverse functions. So you're given f of x and g of x on both of these, so we need to verify that that they are inverse functions. So answer could be yes or no. So to verify that, we're going to do f of g of x, and then g of f of x, to make sure that if they both equal x, then they will be inverse functions. Okay. So for the first part, so let's do the composition of f of g of x. So we're going to plug this function right here into that location right there. So f of g of x is equal to the cube root of, we'll have 8x cubed plus 6, then minus 6 divided by 2. Okay, then simplify, so this is going to be equal to the cube root. Now I can simplify those, that's going to be 0 right there, so it's going to be 8x cubed divided by 2. Okay, now I'm going to, so since this is a cube root, I can evaluate these separately. So this is because it's a cube root, we're dividing, that's why we can do that. So it's going to be cube root of 8x cubed divided by the cube root of 2. Okay, so that's going to be equal to, the cube root of 8 is 2, and the cube root of x cubed is going to be equal to 2 as well, or x to the third, sorry, or it's just going to be x, and then divided by the cube root of 2. think I might have done something wrong here. Let me go ahead and rewrite this because I think I'm doing something wrong. So f of g of x is equal to the cube root of 8x cubed plus 6 minus 6 divided by 2. Okay, and then that's going to be equal to the cube root of 8x cubed divided by 2. Okay, and then that's going to be equal to... Okay, I think I know what the problem is here. I think I wrote this wrong whenever I was typing out the test. I'm going to correct it on your key. So this should be the cube root. This should not be in a cube root. Okay, that's going to make it a lot easier. So we have the f of x is equal to... let me go ahead and write this differently. In fact, you know what I'm going to do? Sorry, I have to edit this mid-video. Okay, so this should be equal to the cube root of x minus 6 divided by 2. Okay, so that's going to make this actually solvable the way that it was meant to be solved. Okay, so again, I'm just plugging this into that location right there. So we got f of x is equal to the cube root of 8x cubed plus 6 minus 6 and then divided by 2. Okay, so I get f of x, sorry, that's supposed to be f of g of x. So f of g of x is going to be equal to, those right there are going to cancel, so I get the cube root of 8x cubed divided by 2. And then the cube root of 8 is 2. The cube root of x cubed is x, so I get 2x divided by 2, and then that's going to be equal to x. So there's a check right there. And now I also need to check that the opposite composition works. So g of f of x. So this time I'm plugging f of x into that location right there. So I got I got 8, and then here I'm going to write the cube root of x minus 6 divided by 2 cubed. So that's an important part right there. That's going to be cubed. That's going to be cubed right there. And then this is going inside of the x location. Don't forget that it's plus 6. Okay, so this is going to be equal to 8 multiplied by, now when I cube this numerator right there, because I can cube both numerator denominator, that's going to make it x minus 6. And then when I cube the denominator, that's going to be equal to 8, then plus 6. Okay, these will cancel because that's 8 on top, 8 on the denominator. So that's going to be equal to x minus 6 plus 6, and that's going to be equal to x. So there you go. We were able to show that they both equal x, and therefore they are inverses. So f and g are inverses. So you need to show both those. Okay, now for 33, let's go ahead and do a very similar process. So let's find f of g of x. That's going to be equal to 4. And then I'm going to plug in this right here. It's going to be negative x minus 3 divided by 4 squared. Then it's going to be plus 3. This is going to be equal to 4. Now, if I square this entire thing right here, that's going to be positive, first of all. That's going to be x minus 3 squared over 16. So that's going to be 16 because you can square both top and bottom. Okay, and then it's going to be plus 3. I can already tell that this is not going to work out. This is going to be x plus 3 squared, so this is going to be equal to 4x squared minus 6x plus 9. That's what's going to be, that's what this is going to become. And then all that's being divided by 16 plus 3. So you can see that this in no way is going to result in you getting x. So this is not going to be equal to x. Therefore, we can already stop here. So f is not an inverse of g. So there you go. Okay, so that should be the whole practice test. Hopefully you guys found this useful, and good luck in your studies.